I have to apologize, my German is not at the level that would be deliverable, so unfortunately you're going to have to try to understand my English for what it's worth. As my host mentioned, my name is David McKittrick. I'm Senior Application Specialist with a company called Blue Marble Geographics. Blue Marble recently acquired a fantastic product called Global Mapper, and I know some of you are familiar with Global Mapper. Some of you have stopped by the booth, and I appreciate you coming to listen to my little spiel. A lot of people use this software, Global Mapper software, for very basic data conversion. It is a piece of software that supports over 200 formats for both importing and exporting data. It can be your data can be reprojected, can be transformed, can be edited, and I know a lot of people use it for that very specific purpose. What I find when I deliver presentations or conduct training sessions is that many people who think they know Global Mapper quickly learn that they don't, and there's a lot of functionality in here that they're not aware of. So my job over the next 20 minutes is to introduce you to some of the more kind of ingrained functionality in Global Mapper and to hopefully expose you to something that you were not aware of. I'm not a big PowerPoint person. I hope you don't mind. I'm actually going to run the software. No safety net here, so wish me luck. Specifically, what I'm going to look at today are some of the terrain functions in Global Mapper. The Global Mapper supports several dozen terrain data sets, terrain formats. This particular example that you're seeing behind me is simply some data I downloaded from the USGS digital terrain, DEM, digital elevation model data. It will work with LiDAR. I'm not sure I'm going to have time during my presentation, but if you want to see Global Mapper working with LiDAR, creating some gridded elevation data sets from some LiDAR point cloud data, I'll give you the booth number in a little bit, and we can conduct further this demonstration at our booth. So the display of our this elevation data, you can see it's rendered on the screen. This is just a very small subset of my data set. I want to show you quickly one of the variations in our shading. This is just a simple change in the structure of the elevation where we're now looking at actual slope values instead of actually elevation data. So you can see by the color scheme on my legend, the flatter areas would be white. And this is a same elevation data set, but just rendered in a different way. So we can view the data either by slope angle or by slope direction. So if you want to see your south-facing slopes or your west-facing slope, agricultural applications perhaps, or installation of solar panels, you can adjust the rendering of the shading in those ways as well. So there's a lot of different ways of rendering this data. Obviously, with any 3D elevation data, it's also a good idea that we can render this as a 3D model, and Global Mapper includes a 3D modeling function as a standard. I'm going to increase my terrain exaggeration slightly, and we can pan and move around in the terrain and see some of the terrain features accentuated a little bit or exaggerated a little bit. One of the really nice features of Global Mapper in this 3D view is the ability to render water level. By default, water would be at a 0 meter elevation. We can model this, as you can see, intruding in the landscape. So here we can get an idea what the impact on the terrain would be with incremental increases in water level. And that can be specified. I'm just clicking the button to increase it in 10-meter increments, but it can be specified. So if you want to see what areas are going to be impacted by a potential rise in water level, you can model it in this way. So a nice visual representation of what the effect of water level rising would be. And we can also, I'm just going to close my 3D model for the time being. We can also render the same model with some aerial imagery. I've got some half-meter resolution aerial imagery. And again, if we open up our 3D view, we now have the imagery draped. Same functionalities available in here. So a simple viewing of elevation data, certainly supported zooming and panning around within the application. One of the other applications, one of the other functions we support, and it's something that a lot of people use very commonly, is just simply generating contours. We have an elevation model in place. My client needs to just simply look at the 1 meter contours, and it's a very simple process in Global Mapper to generate contours. We can specify a contour interval, define the minor and major contours to accentuate specific contours. I'm not going to go ahead with this. We'll just show you the functionality that's available. And again, it just generates your contours in a vector format, can be easily exported to CAD, to any GIS application, and can be written into a spatial database if you're using that technology. So contour generation is another terrain application in Global Mapper. Some of the analysis tools I want to show you, again, very quickly. This is a very specific application that's been developed primarily for the energy industry, where we can actually calculate volume measurements within a given elevation data set. Now, what I've simulated on the screen right now is the potential construction area for a facility, or perhaps it's an oil well or some sort of maybe commercial facility, and it's just outlined simply with a polygon such as you see on the screen. Now, the first thing I can calculate here, based on my projected location for that, is a break-even elevation, essentially. You know, what would be the terrain elevation if I was to flatten this area? What would be that optimal height that would allow me to flatten the terrain without having to remove any material or without having to bring in any material? So in other words, taking material from one side of my proposed construction site, moving it to the other side to flatten it. And we can essentially calculate that value. What is that break-even height? And it's a very simple calculation process within Global Mapper, where I select the designated area, and I simply go to my volume calculations or my cut and fill calculations, and I check this box. And by doing that, I'm not going to go through with this again in the interest of time, but it will tell me at what elevation I can break even. In other words, establish that defined height where I can make the process of flattening the terrain more efficient. Now, beyond that, and this is where I'm going to demonstrate, we can take that elevation value and we can plug that in and actually calculate specifically the volume of material that was going to have to be moved within this site. And I'm actually going to plug that value in here. I'm cheating a little bit because I've written it down. So it's 103.752 meters. And that's the precise break-even height within that area that will allow me to move the terrain around. So I'm plugging in that height, and I'm going to simply click OK on this dialog box, and it will compute for me the precise volumetric measurements of material that will need to be moved to flatten. So you can deliver that to a contractor, to your engineers, and say, this is how much material will need to be moved in order to flatten our terrain within that specific location. Now, over and above that, with that value in place, we can assign that value to the area that we created and create an artificial elevation, essentially flattening the terrain to model what that would look like. And again, in preparing for this, I've already plugged that value in to this particular area. All I need to do is create a flattened terrain model, which I can do by simply selecting terrain. This is going to create a modified grid. I'll just go with the default settings and click OK. And what I've created in the middle here is a small area that's flattened to that precise elevation that I defined. And to visualize this, I'm going to simply render this area in 3D. And difficult to see at this scale, but you can see the modified terrain now displayed. Kind of difficult in the light here, but it's a flattened model. We calculated the volume of material need to be moved, and we've modeled that. Now, the other thing that we can do as part of this process is we can start to model some of the vector features, building footprints, for instance. We're going to be constructing a building on this that's maybe 3 meters tall, and we can start to model those things, so the mapping becomes essentially an entire 3D process. And these are all functions that are available in Global Mapper as a out of the box. There's no plugins required for this type of application. So that's just one of the terrain analysis functions that's available. Quickly going to jump to another location. I have all this prepared. So one of the other analysis functions is watershed analysis. We can generate a complete map of the watersheds within this area. Watersheds essentially the catchments area for hydrological modeling. Or we can generate a watershed model that analyzes water flow, potential water flow. And again, this may tie into what we were describing previously, where we were essentially simulating a construction. Well, based on any regulatory issues in that area, we may have to map where the outflow of water would be from that location. And again, I've simulated this right here. I want to define this as my construction site. Where is the outflow? Where will the water flow from that location? And it's a very simple process for me to generate some watersheds. All I'm going to do is trace the flow from this point to its destination, which in my case is going to be the edge of my elevation model. I've cropped my elevation to a fairly finite area. And I'll make sure I can see the button at the bottom of my screen. There we go. And it's basically going through this watershed calculation process, analyzing the terrain. And you can see that water flow is now mapped, as well as the other potential stream beds. This is not necessarily where the streams are, but this represents the potential for the terrain to support the flow of water, based on some of the variables I would have plugged into that first dialog box that you saw. So this is my water drop analysis. The opposite of that, I'm going to just temporarily shut off that model, and I'm going to go through the same process again. Instead, this time, I want to develop a watershed model that shows me the area that will flow to a specific point. So essentially the catchment area for a defined point. And again, for regulatory issues, you need to define a watershed for public water supply mapping, things like that. This is the point that I'm interested in mapping. I go through the same process once again. But in this case, I want to generate a watershed showing drainage to this particular point, and I can define a threshold, a pixel threshold beyond my selected point, to give us a little bit of flexibility. I think 1 should be fine in this case. And once again, my resolution is such that my buttons are disappearing. There we go. And in this case, you'll see again the same process is going on, but in this case, the end result will be an area feature that defines the catchment for that particular point. So the water flow into that point. And again, as I said, for regulatory issues, it's a very, very useful tool for determining the catchment area. Essentially, what this outline would represent would be the ridge lines that surround my defined area. So water flow analysis, watershed generation, and potential stream modeling are another part of the standard functionality within Global Mapper. Again, what we're looking at here are specifically functions that relate to interacting with elevation data, whether that's derived from some LiDAR data you've had or some other elevation data source. And continuing with that theme, I'm going to select a slightly different model. Now, in this case, I'm going to do a couple of terrain analysis that will allow me to map initially a line of sight and kind of as a byproduct of that, a view shed, basically 2 variations on the same theme. So first of all, I'm going to turn on this linear feature. Now, this would represent possibly the path from a transmission location. Maybe we were constructing a transmission tower. The other end of my line might be where I wanted to detect if that's received. Now, this is a single linear feature. This is a single line that we're analyzing. And the process, again, fairly straightforward. I'm simply selecting the line. I'm going to ask it to conduct a line of sight analysis. Initially, what's going to happen is it's going to generate what's called a path profile. Based on the underlying terrain, I've got a cross-sectional view, like cutting away the terrain. Believe me, it's very much exaggerated. I've been in this area, and it doesn't look like this. The vertical and horizontal scales are very much offset to accentuate the terrain. But you can see, based on this model, that there's some undulation, some terrain variation between point A and point B. What I can do as an analysis of this, I can actually determine, based on my point of origin, my destination, if there actually is a straight line of sight or if there's any obstructions. And I'm going to plug in a potential height from my site. In other words, I'm exaggerating the initial point of origin by 20 meters, perhaps a transmission tower or something of that nature. And my 2 elevation, I'm going to make that about 2 meters, approximately the height of the average person. If I'm holding my cell phone to my ear, can that transmitted signal see my cell phone, which is not at ground level, it's about 2 meters up. And we'll just conduct this analysis, and again, there's various options can be plugged in here relating to the nature of the transmitted signal. And we'll click OK. And it looks like in this case, from that artificial elevation to my destination, I've got a clear line of sight. We have a lot of users who have applied this functionality literally for visibility. Can this structure be seen from another location? Is it going to be visually impacting the view from a particular location? And it can be used for that application as well. My time is almost up, I know. I want to show you one more function related to what I've just shown you, except in this case, my analysis is going to be based not on a single linear path, but on a 3-dimensional or a multi-directional view, if you like. I'm defining the point of origin in this case, potentially, again, a transmission tower. And I conduct a view shed analysis in this case. So again, we're going to analysis measurement, and we're going to calculate a view shed from this selected point. Many more options. And for those of you who may be in the transmission business, a lot of these variables may be meaningful where you can do things, for instance, Fresnel zone calculation, freeze path loss. That relates to transmitted signals and the loss of signal over distance. In our case, we're going to keep this straightforward. We're going to plug in the same values as before, a 20-meter height above ground, 2-meter receiver range. My view radius, I'm going to make 4 kilometers. I'm not interested in anything beyond 4 kilometers. But I want to find out not specifically those areas that I've got coverage, but I want to find out those in which my coverage is not available. So I want to display my hidden areas. And again, we'll go with all of the other variables. Oh, one other thing. The extent of my calculation is based on a 20-degree start angle right around the middle of my screen right here. And from that 20-degree start angle, I want to analyze from 180 degrees. So in other words, a complete half circle from that start angle. So that's 20-degree start angle, 180-degree swept angle. And this process takes a little bit longer. It has to analyze the terrain. It's going through and monitor, determining what would be visible. Eventually, it will fill in. And you will see, again, remembering that we're going to be mapping those areas that I don't have coverage, assuming it's a transmission. The red areas are areas of concern. If I put a 20-meter transmitter right here, you can see the amount of shadow. I may want to consider another location for my transmitter in this case, or I may want to put in a second transmitter to cover those areas. Now, again, this is solely based on an analysis of the underlying terrain and the visibility of features within that area. Looks like I have a few minutes, which is good. I've gone a lot faster than I thought I was going to, because I do want to show you the way that Global Mapper works with LiDAR data. I'm going to show you again, we'll unload what we have, a very specific example. And this is a very small subsection of some LiDAR data. This happens to be some aerial imagery of the state capital of the state in the US that our company is in, which is state of Maine. I imported some LiDAR data, LAS format, and you'll see this is actually the point cloud. I could have processed it during import to create an actual elevation grid, but I want to show you the point cloud itself. There are, and you can see perhaps up here is just short of 500,000 points within this area. And we can randomly select a point, and you can see the information that's tagged to those points. So based on this simple point cloud, I can very quickly and very easily generate an elevation grid based on the parameters I plug in here, my vertical units, etc. Again, I'm just going to go with the default values, and it will create a very accurate terrain model. And I'm limiting this particular analysis to simply the ground points, not any canopy or any building layers. And I'll turn off my points. And once again, this can be rendered as a 3D model if we turn on our 3D functionality. Very simple, very easy to work with 3D, to process LiDAR data or any other point cloud data and generate elevation models, generate contours, or any of the other processes I showed you. So once again, Global Mapper, it's a desktop GIS application. Got a lot of format support, a lot of processing capability, both data in, data out. But hopefully, as you've seen in this very brief demonstration, there are a lot of other functionalities functionalities available for processing elevation data. And I thank you for your attention. I had to write this down because I keep forgetting. Our company is at booth 8D46, which is in the next hall over. We're going to be there for the next few days, and if you want to see a little bit more about what Global Mapper is all about, some of the functionality, then feel free to stop by. And thank you.